All right, the next section we want to study, section 2.4, is just another look at the graphs of lines. We're going to look at some special cases. We're first going to start with horizontal and vertical lines. So here we have the graph of a horizontal line, and I need to make some changes here. To indicate this is a line, we really should have arrows on both ends showing that it goes on forever. My graphing utility didn't do that when I made this picture, so I'm going to do it myself. First thing we want to consider is what's the slope of this line. And maybe you remember, or maybe you can tell just by looking at it. If not, well, we could go back to our old slope formula. Let's just take 2 points on the line and throw them into this formula, y2 minus y1 divided by x2 minus x1. Let's see if we can pick out some points on this line. I'm going to pick about this one right here. That appears to be the point. Well, let's see, x is 0 here, and y looks like it's 4. Let's pick another one. How about this one here? Here's that x is 5, and well, y is still 4. I just plug those into my formula. I'll just let the purple one be the second point and the orange one be the first point. The order doesn't really matter so long as you keep the order that you've chosen once you have chosen it. So y2 is 4. y1, also 4. And you may see what's about to happen here. x2 is 0. And x1, 5. So what happens? My numerator, 4 minus 4, that becomes a 0. My denominator is negative 5. 0 divided by anything that isn't 0, such as negative 5, is just 0 again. So the slope of this line is 0. What is the y-intercept? Recall the y-intercept is where the line crosses the y-axis. Just by inspection, in fact, I picked it out here. There. That's the y-intercept. It's the point 0, 4. So we can actually generalize some observations about horizontal lines. We call those constant functions because no matter what x is, y is always a constant number. If we look up here at our example, x is 0, y is 4, x is 5, y is 4, x is 10, y is 4. It's always constantly 4. So observation the first. The slope of any horizontal line, well, it's 0. We've discovered that. And we can see why. The numerator will always be 0. I'm subtracting the same constant from itself. Our function, the graph of any function of the form, well, here's what it's going to look like. It'll be some function f of x equal to some constant number b. So b is just some number. I'd like to go to the old familiar y equals, then it's y equals b. This tells us our graph is a horizontal line. It crosses the y-axis at the point x equals 0, y equals b. So looking at our friend here, we would say that this is the line f of x equals 4, or if you prefer, y equals 4. All right, our turn to give it a little try. If we want to graph the line f of x equals -2, notice this is a horizontal line. It says that no matter what x is, y is -2. Down here, here's -2, -2, -2. No matter what x is, y will be -2. So I can just draw my little line in there on the y equals -2 spot. Put some arrows on the end to indicate that that line goes on forever, and we've got it. All right, we looked at horizontal lines. Let's next consider vertical lines. I've got the graph of a vertical line here. Make my alteration. There we go, fixed it. Let's consider what the slope of this line is. Again, I can pick 2 points on the line. This one here. Pick a different color here. All right, what is x at this point? It appears to be 3. And y is 0. Anytime we are on the x-axis, y is 0. And I can pick another one. X is 3, and in this case, y is 5. Back to our slope formula. It says y2 minus y1 divided by x2 minus x1 is the slope. I'll just keep that purple one as the second point, and the orange one is the first point. Y2 is 0. And y1, 5. X2 is 3. And x1 is 3. This gives me a -5 in the numerator, and a 0 in the denominator. And at this point, alarm bells should be going off, as I believe we've been told since infancy. We can't divide by 0. We don't allow it. Some strange stuff happens when you attempt to divide by 0. So division by 0 is called undefined. So our slope here is undefined. What's the y-intercept of the line? Well, let's see, where does it cross the y-axis? In fact, it does not. And that can happen. Just to our little summary box. Let's throw in here. Let's see the slope. The slope of any vertical line we've found out is undefined. What about the equation? And the graph of the equation of some form. Well, it's not y equals. Notice that y was changing. Y was changing, but x was the same. In fact, in the case of a vertical line, it is x is equal to some number. We'll say a. So the graph of any equation of the form x equals a is a vertical line. It crosses the x-axis. It's not necessarily going to cross the y-axis, but it will cross the x-axis, and it will cross the x-axis at the point x equals a and y equals 0. All right, let's try it out. Let's graph x equals -2. Come down here to my x-axis, horizontal axis, find -2. X equals -2 here, here, here. So I'll just fill in this vertical line Arrows on the end indicate it goes on forever. And there we have it. Is that a function? Is a vertical line a function? If we perform the vertical line test on this thing, you will notice that it will fail, as it itself is a vertical line. So is a vertical line a function? No, no, it is not. Justification being that it fails the vertical line test.